first main topic this year will be physical properties of matter. We start with this topic because it will be a recurring theme throughout the school year. Physical properties of matter are all around us, in and on the earth, the physics of motion, and even in space. Why is it that way? Well, first, we need to remember that matter makes up everything around us. Even the tiny atom, which is the building block of all things, is made of matter. But what is matter? Matter is anything that has mass and volume. In other words, anything that has stuff and takes up space. So if we think of an atom, it is made of three parts, which we will learn about later, that has mass, called atomic weight, and each atom takes up a certain amount of space. And since all things are made of atoms, everything is matter. During this lesson, you're going to define terms that are important to understanding the physical properties of matter. I would like you to put these terms in your notebooks that I have given you. This notebook will be available to you during labs and some assessments, so it would benefit you to keep good notes. You may never know when you'll be able to use it. Also, many students find it easier to use a notebook when working on assignments on the iPad. That way you don't need to keep multiple items open on your iPad at one time or try to switch back and forth. The first term in your notebook is physical property. Physical property is defined as properties that can be observed or measured without changing the chemical makeup of the substance. Let's think about that for a moment. Somewhere in science you should have learned the difference between a physical change and a chemical change. What is something you remember about physical change? A physical change occurs when matter changes shape, size, or state, like solid, liquid, or gas. That means that the object doesn't change what it is made up of. It simply changes how it looks. An example would be a piece of paper. If you take the paper and crumble up, it is still paper. It hasn't changed. It just has changed shape. Well, if you take that piece of paper and burn it, it is now changed chemically because it is no longer paper. It has been broken down into elements it is made of, like carbon. Another way to think about it is, you can reverse a physical change, uncrumple the paper, but you cannot reverse a chemical change, unburn the paper. This all relates to how to think about physical properties. These are things that affect matter in a physical way. It will not change what the matter is made of chemically. Our next term is volume. I want to point something out to you about how the notes are structured for the rest of the presentation. There will be three parts: what, why, and how. The what is the definition. The why is the reason we need to learn this term. The how is the method used to test or calculate the term. So let's see how it works for volume. The what is the quantity of three-dimensional space occupied by solid, liquid, or gas. Volume is sometimes referred to how much space the object takes up or how big that object may be. The why, multiple uses, measuring solids, liquids, and gases. Volume is essential to find the density of an object, which is a term we will define shortly. The how depends on the object. Volume of solid is length times width times height. Liquid and gas use a designated container like a graduated cylinder. You should have learned in 7th grade, or maybe even before that, how to find the volume of a three-dimensional solid. Length times width times height has to do with a cube. There are other formulas you should have learned for other types of shape. Can you think of any? There's a special method to find the volume of what is called an irregular shaped object, something that does not fit into any three-dimensional category. It could be a number of things: a nail, a set of car keys, or your pencil. The name of that method is called the water displacement method. This is not an actual physical property. It is a technique used to measure the volume of an irregular shaped object. Let's look at the steps. Step 1. Fill a graduated cylinder with water to a designated level, like 50 milliliters. Step 2. Drop the object into the cylinder and read the new water level, maybe 54 milliliters. Step 3. Subtract the first reading from the second reading. That is the volume of your object. So we take 54 milliliters, subtract 50 milliliters. That means the volume of our object is 4 milliliters. And just a little note here. 1 milliliter is equal to 1 cubic centimeter. The following video will give you an example of the water displacement method. Mass. Remember, matter is anything that has mass and volume, so it is important to understand what mass is. The what is a measure of the amount of matter in an object. In other words, how much stuff is in an object. The why, all matter has mass. The how, use of a scale. Base unit for the metric system is grams. Now a little note here, in science class we used the metric system. The term is usually interchanged with the word weight. As this is not entirely wrong, it is not entirely correct. Weight is technically the mass of an object multiplied by the force of gravity. So on Earth, the terms mass and weight are used interchangeably. However, if you were to land on the moon, your weight would change because the force of gravity on the moon is different than on Earth. But your mass would not change. You still have the same amount of stuff on the moon as you did on Earth. So we will try to use mass and weight appropriately as often as we can. We will learn more about weight during our physics section. Density is our next physical property term. The what describes how much mass is in a specific volume. Why determines whether an object will sink or float in a liquid or gas. And the how. Density is equal to mass divided by volume. The density of pure water is 1 gram per milliliter. This measurement is used to compare the densities of other objects. If an object has a density greater than 1 gram per milliliter, then that object will sink. If the object has density less than 1 gram per milliliter, then that object will float. Let's take a look at the formula of density another way. The formula for density is mass divided by volume. However, there are times that we know the density and volume of an object, but we don't know the mass. Therefore, we need to rearrange the formula to fit our needs. This chart helps to understand how to rearrange the formula to calculate what we need to solve. Example, if you want to know the mass of an object, you would multiply density by volume. If you were solving for volume, you would divide the mass by the density. You will see this type of formula chart throughout the year. Conductivity is our next term. The what describes how well something conducts electricity. What do you think of when you hear the word conduct? In this instance, the word conduct means to let through or allow to move. So when dealing with electricity, it is the substance that lets the electricity flow through it. Why? Can help to identify the substances that make up an object. How? Conductivity meter or some other type of electrical setup. The ability of a substance to allow conductivity can give us a clue as to what the substance is made from. Not all substances are good conductors of electricity. We will focus on this concept later in the year. How can we find out if a substance will conduct or is conducting electricity? There are meters that can be used, or we can create a setup that can test for conductivity. Magnetism is probably something everyone has experienced. Most of you probably have magnets hanging on your refrigerator at home. However, even though we are familiar with magnets, we may not clearly understand why magnets function. So our what describes how matter responds to a magnetic field. This is the concept that confuses most people. When an object is magnetic, it either has a field around it or it reacts to that field. Let's think about the magnets on a refrigerator. The magnet has a field of energy around it. A substance that has the ability to react to that field will respond when in the field. So, the refrigerator responds to the magnetic field. Yes, I know the magnet sticks to the fridge, but in reality, the fridge is responding to the magnet. Why does the refrigerator react? It has to do with what the refrigerator is made from. So that brings us to our why. Why can help identify the substance that makes up an object. Only iron, nickel, and cobalt are magnetic. This means that those are the only elements that react to a magnetic field. Many people think that if an object is made of metal, then a magnet will stick to it. Have you ever tried to get a magnet to stick to a soda can? It doesn't work, does it? That is because the soda can is made from something other than iron, nickel, or cobalt. So how do we check if an object is magnetic? We use a magnet. Let's go back to the refrigerator. The magnet sticks to the refrigerator because it is made from either iron, nickel, or cobalt. We know that because the magnet sticks. Most likely, the refrigerator is made of steel, which is not an element in the earth. Steel is made from a process in a factory that combines iron with other substances. Now that we have all the terms put in your notebook, let's reflect on the reasons we spent time writing all this down. It is important to remember that everything is made of matter. There is nothing on this planet that is not made of matter. Physical properties help us to identify what an object is made from. Objects can be made from all types of substances. Physical properties can help us to narrow down what those substances may be. Physical properties tend to be easy to identify and test. Unlike chemical properties that usually need chemicals or large amounts of equipment to test, physical properties are usually ones that can be done relatively easy.